Hey guys, I am Varshit pursuing my BTech at Institute of Aeronautical Engineering. Today I'm going to discuss about normal distribution properties and its applications. Normal distribution. Earlier days, it was difficult for users for just plot and histograms and line graphs etc. So, normal distribution properties are discovered. See, these normal distribution properties are nothing but which actually plots probability. This distribution properties are both associated with graphical representations and also probability outcomes. Also, see, that's why normal distribution properties. Normal distribution was was given more priority for mathematicians. See, let us dive deep into the normal distribution and its properties. So today we are going to discuss introduction to normal distribution, characteristics of normal distribution, z-scores and percentiles, central limit theorem, which is going to be important for finding out the normal distribution, applications of normal distributions. Yeah, normal distribution. Uh, So I'm gonna introduce normal introducers to you. So yeah, what is normal distributions basically? A normal distributions, also known as Gaussian distributions or a bell curve, is a continuous probability distribution characterized by its symbol, the symmetrical bell-shaped curve where data is centered around a mean and exhibits specific properties as described in previous answer. And here's a simple figure representing a standard uh, normal distribution. Symmetric Symmetry in a normal distribution means that the data is equally likely to be above or below its mean, creating a balanced portion. This symmetry results in a bell-shaped curve, which is characterized by single peak at the mean, gradually tapering off uh, towards both falls. The mean point on the curve, but or the mean is most probable value. While values further from the mean it becomes increasingly less probable. But this distinctive bell curve is a hallmark of the normal distribution and is essential in understanding how data is distributed in many real world scenarios. In the context of a normal distribution, the two primary parameters are mean and the standard deviation. The mean represents the central or average value on which data is symmetrically distributed in bell-shaped curve. It serves as the peak of curve that indicates most probable value in distribution. The standard deviation measures the spread of variability of the data points from the mean. A larger standard deviation results in wider and a flatter curve, indicating greater dispersion, while a smaller standard deviation leads to a narrow, taller curve, reflecting less variability. Together, the mean and standard deviation defines the characteristics of normal distribution and play a pivotal role in statistical analysis and interference. So that is a quick recap on normal distribution. See, a normal distribution is nothing. See, it's a bell-shaped curve which is basically symmetric in nature. Let us assume this as the xy. Let us assume a xy graph, and let us draw a bell-shaped curve on it. See, these both are if the probability of the curve is 1, then we it gives us whole curve, as you see in the you know in this graph. See, let me zoom it out for you. Yeah. See, if x is continuous variable having a normal distribution with the mean mu and standard deviations sigma, you can graph a normal curve with the equation y is equal to 1 by sigma root over 2 pi e power uh, nu root over x square minus nu square by 2 sigma square. Okay, characteristics of normal distribution. Okay, in a normal distribution, the mean represents a central or average value around which data is symmetrical distributed. It serves as a peak of a bell-shaped curve indicating the most probable value in the distribution. The mean is calculated as arithmetic average of all data points in a distribution. In median, in normal distribution, the median is the middle value that divides the data into two equal halves. Due to symmetrical nature of distribution, the median coincides with the mean. It represents the central point where half of the data value are greater and half of are smaller, and making it a measure of central um, tendency in normal distributed data mode. In a normal distribution, the mode represents the value that occurs the um, highest frequency, coinciding with both the mean and median. This unique property of normal distributions means there is only one mode, and it is located at the peak of the average symmetric bell-shaped curve. In other words, in normally distributed data, the mode is same as the mean and median, making it a central measure of the most frequent value. Spread refers to extent or range over which data values are distributed within a normal distribution. It quantifies how far apart data points are from each other in normal distribution. The spread is influenced by the standard deviation. A large standard deviation results in wider spread, indicating the data points are more uh, depressed, whereas a small standard deviation leads to narrower spread, indicating the data points are closely clustered around the mean. Variability is a measure of the extent to which individual data points deviate from mean in a normal distribution. In other words, it characterizes how individual values differ from average. A high degree of variability is associated with large standard deviation, signifies the data points are widely spread out from conversely, low variability is linked to a small standard deviation, indicating the data points are closely clustered around. So here you can see relative mean positions. Yeah, zero skewness, mean equal to median equal to more. Um Positive skewness, mode greater than, mode less than, median less than mean. Negative skewness, mode greater than, median greater than mean. A measure, okay, Z scores, a measure of how many standard deviations below or above the population mean. A raw score is called Z score. It will be positive if the value lies above the mean and negative if it lies below the mean. It is also known as a standard score. It indicates how many standard deviations an entity is from the mean. In order to use a z-score, the mean nu and also the population standard deviation sigma should be known. A z-score helps to calculate the probability of a score occurring within a standard normal distribution. It is also enables us to compare two scores that are from different staples. A table for the value sigma indicating the values of a cumulative distribution functions of normal distributions is termed as a z-score. Yeah, you can actually see the formula for finding a z-score, which is z equal to x minus nu by sigma. A set of economics final. Okay, so it's an example sum given. A set of economics final exam grades are normally distributed with a mean of 65 and a standard deviation of 12. Okay, finding a z-score where the z-score of a grade of 70, that equal to 70 minus 65 divided by 12, that will give us 0.42. Similarly, z equal to 62 minus 65 by 12, that will give us negative 0.25. So yeah, these are some problems related to z-scores. Now let us dive deeper. Percentiles. Together, z-scores and percentiles are valuable tools for accessing the position and significance of individual data points within the tools for accessing the position and significance of individual data points within a distribution, making them important for statistical analysis and data interpretation. Percentiles represents the relative rank or position of a data point with within a data set. The 50th percentile is the median which divides the data into two equal halves. Percentiles are often used to understand how a data point compares to other data points in same data set. For example, 75th percentile means the 75% of data points are below it and only 25% are above it. Skewness and kurtosis. Skewness is statistical measure that assesses the asymmetry of a probability distribution. It quantifies the extent to which the data is skewed or shifted to one side. Positive skewness indicates a long tail on right side of distribution, while negative skewness indicates a longer tail on left side. Skewness helps in understanding the shape and outliers in a data set. If the values of specific independent variables are skewed depending on model skewness may violate model assumptions or may reduce interpretations of feature importance. Kurtosis is a measure of tailness of distribution. Tailness is how often outliers occurs. Excessive kurtosis is the tailness of distribution relative to normal distribution. Distributions with medium kurtosis are mesokurtic. Distributions with low kurtosis are platykurtic. Okay. Central limit theorem. The CLT is a fundamental concept in statistics. It states that the uh, sample mean approaches a normal distribution as the sample edge increases regardless of population, identifying distribution applications of normal distribution. The CLT is especially relevant when dealing with population that are not normally distributed. It allows to treat the distribution of sample means as approximately normal, making statistical interfaces more robust. Examples. Suppose we have a population with a high skewed distribution, such as distributions of individual household incomes. If we take numerous random samples of mm, fixed edge from the a population and calculate the mean of each sample, the distribution of those sample means will approximate a normal distribution as the sample edge increases. Okay. The present. Okay. Okay, heights of individuals provides a comprehensive overview of how height data conforms to normal distribution. It covers characteristics of height data is really its real world applications and importance of visualizing through examples explanations. It highlights the practical use of percentile z scores for understanding height and data relevance. And you can able to see here uh, heights of 18 and 20, 18 to 24 year old males in US are approximately about with approximately normal with mean 70.1 inch and standard have a mean of 64.8 inch. Estimate the percent. Okay, z equal to 72 minus 70.1 divided by 2.7 equal to 0.7037. uh, p pz greater than 0.7037 minus normal CDF 0.7037 to 10 equals 0.2408, that equal to 24.08%. Estimate percentiles of US females between 18 and 24 who are between 5 feet and 5.5 are z equal to 65 minus 64.8 divided by 2.5 equal to 0.08. To create histograms plus plots to visualize height data, you would first gather your height data set, then histograms divide the data into bins and count the number of data points to each bin. Plots these counts on y-axis against the height ranges on x-axis. For a density plot, you use a smooth curve to represent distributions of heights, showing the density of data points at different height values. Both methods provide a clear visual representation of how height data is distributed, helps to identify patterns such as whether it follows a normal distribution or exhibits skewness or kurtosis. In the context the clothing and apparel industry, the understanding the normal distribution of heights is crucial for designing clothing that fits a diverse customer base. By Analyzing height data, manufacturers can create size ranges that accommodate the majority of customers, minimizing the likelihood of ill-fitting garments. The This knowledge will also helps in production of standardizing clothing sizes, reducing the normal of returns and enhancing customer satisfaction. Okay, the normal distribution is widely used in businesses for various purposes like quality control. Many manufacturers processes follow um, a normal distribution, and companies can statistically process control techniques for to monitor uh, the quality of their products by measuring the mean and standard deviation of the process. Companies can set control limits to ensure the process stays within acceptable bounds. Okay, one second. Okay, common mistakes: misinterpreting skewness. Some mistake positive or a negative skewness for normal distributions. Over reliance on sample size, assuming the CLT applies with very small sample size. Understand the skewness, learn to recognize skewness and understand its impact on data distribution. Use approximate sample size, ensures your sample size is adequate for CLT to hold. Okay, a significance for application. Conclusion: understanding heights and data is fundamental aspect, and the normal distribution applications also give us major advantages over estimating a market and data handling, etc. So I'm Varshit signing off for this session.